Here we're going to be learning about the distributive property. So the distributive property is a way to simplify expressions. It's when we have a number or a variable that's sitting outside the parentheses, which means we're going to multiply times that stuff. And to distribute really means to multiply all the terms inside the parentheses by the number on the outside of the parentheses to simplify the expression. So we take whatever's on the outside of the parentheses and we multiply it by everything inside the parentheses. So A gets multiplied times B. That's what that's showing there, A times B. And A gets multiplied times C. That's why we're showing A times C there. Same thing on the number example. 2 gets multiplied times the first term, so that becomes 2x. And 2 gets multiplied times that negative 4, which becomes that negative 8. So we distribute the number in front into all the terms on the inside of the parentheses. Another way we could see this is with an area model. It's basically just a picture of what we were doing there. We want to show that 3 is going to get multiplied into both terms on the inside. So we're going to show 3 here, and then each term split up in the top. So we have 4x and 5, and we're just going to show the multiplication happening there. So we show the product of 3 times 4x here. That would give us 12x. We're just multiplying it times the coefficient, so just 3 times 4 changes it to 12. And then 3 times 5 becomes 15. So that's showing it as an area. If you wanted to show your final answer, you would really write it as 12x plus 15. That would be the final expression. That's that answer as an area. All right, so distributing is another word for repeated multiplication. You're just repeating that multiplication into everything inside the parentheses. So 3 gets multiplied times, I'm going to rewrite this as 1x. When we don't have a coefficient, remember there is a 1 hiding there. 1x and x are the same thing. So you really want to imagine multiplying 3 times 1, that becomes 3x. And then 3 times 5, that becomes 15. When we rewrite our final answer, whatever the sign of the number is, that sign comes down into our answer. It's a positive 15, so we write it as a plus 15. Now we're going to take this negative 2 and distribute it into both terms here. Negative 2 times 1y and negative 2 times 7. Negative 2 times 1 is negative 2, so that becomes negative 2y. Negative 2 times 7 is negative 14. So again, whatever number we get from this, that sign shows up in our answer. Negative 2y minus 14. The next one looks more complicated, but it's really not. We're still doing the exact same thing. You can multiply negative 3/4 times each of those. Negative 3/4 times 12x and negative 3/4 times 28. So we're going to multiply. Negative 3/4 times 12 is negative 9x. Negative 3/4 times 28 is negative 21. The order actually doesn't matter. If you wanted to write the negative 21 first, you could. Traditionally, you'll just see the x term or the variable term come first. So we're going to write negative 9x minus 21. Again, the sign stays with the number. That's negative 9x. That's minus 21. So in our final answer, that shows up as negative 21. Example 4, when we have a negative sign that's just sitting outside the parentheses, I want you to imagine that as a negative 1. We're going to distribute negative 1 into both of these terms. Negative 1 times 8x and negative 1 times, that is a negative 3. In that expression, I'm sure you're seeing that as a minus 3, but those are really the same thing. It's a negative 3 or minus 3. When we multiply, we have to make sure we include that sign because we're multiplying a negative 1 times negative 3. That would give us positive 3. And negative 1 times positive 8, that gives us negative 8x. In our final answer, it's going to be negative 8x. That's negative. This is a positive, so that's going to show up with a plus sign. So multiply into each term inside, figure out what that number is, including the sign, and rewrite it in your expression. These are going to get a little bit trickier because now we're going to distribute what we just learned about, and we're going to combine like terms. That's what we learned about last time. So distributing is multiplying. That has to happen before we combine like terms because that's adding and subtracting. In PEMDAS, we multiply before we add and subtract. multiplication always has to happen first. So we have to distribute first, then combine like terms. Here we have two opportunities to distribute. We have a 2 sitting outside the parentheses here. The 2 is going to get multiplied into both these two terms. Then we have this 3, this plus 3, that's also going to get distributed into its set of parentheses. So 3 gets multiplied times 4x, and times that 8. So I'm going to write out all these multiplication problems separately. 2 times 1x, 2 times 3, 3 times 4x, and 3 times 8. Multiplying to get 2x, 6, 12x, and 24. All of those are positive. I don't have any negative signs, so I'm going to write everything with a plus sign. So this comes down to be 2x, this comes down to be 6, this comes down to be 12x, that comes down to be 24. Now I can combine like terms, which means I'm going to add anything with an x and add my two constants together. 6 plus 24 is 30. 2x plus 12x is 14x. These are both positive, so I'm going to write it with a plus sign. 14x plus 30x, plus just 30 is my final answer. This is as far as I can go, because remember, like terms have the same variables. This is a constant, this has a variable, so those are not like terms. That's as far as I can go with that. That's as simple as that gets. Next one looks a little bit more complicated, but same idea. I'm just going to distribute negative 2/3 times both of these. And then 4 gets multiplied into the second set of parentheses. So negative 2/3 times 6y, negative 2/3 times 9, and then 4 times 3y, and 4 times negative 3. Multiply these together, you get negative 4y. Multiply these, you get negative 6. Multiply these, you get 12y. Multiply these, you get negative 12. All right, so that's just multiplying everything together. I'm going to skip this step. I don't know if we actually need that. I just want to identify my like terms from this list now. I have a negative 4y and a positive 12y. So that's negative 4 plus 12. That's 8. It keeps the y attached to it. Those are like terms. They have to keep that variable attached to them. Same thing here. These don't have a variable attached to them, so those are also like terms. Negative 6 minus 12 is negative 18. They are going to get a little bit trickier, especially when we're dealing with distributing a negative. This one looks a little bit complicated, or actually it's just a little bit misleading. A lot of people think that we need to distribute this 4, but that's not what it's saying. It's not saying 4 times this stuff. It's really saying negative 1 gets multiplied into the parentheses there. I'm going to write that a little bit cleaner. Negative 1 is the number that's sitting on the outside of that. We're going to distribute the negative 1 into both of these terms. The 4 is not affected by that at all. We're multiplying here. This is saying we're going to do 4 minus whatever comes out of that. 4 and this minus 3m plus 7 are not affected by this multiplication. We're going to distribute here negative 1 times 8m. That's negative 8m. And negative 1 times positive 1. That's negative 1. So really, the simplest way to think about this, if we're subtracting these things, we're just going to change the sign of whatever's in there. That was a positive, it became a negative. That was positive, it became a negative. Now we can combine like terms. I have an m there, I have an m there. I'm going to subtract those two. Negative 8 minus 3 is negative 11m. And then I have 3 like terms for constants here. 4 minus 1, that would be 3, plus 7, that's 10. This one combines all of the confusing parts of the previous questions. We have a fraction, we have distributing a negative, and we have an extra term. I'm going to take this one step at a time. We're going to distribute whatever we have out in front. So we're going to take 1/2 and distribute here. We're going to take this negative 3 and distribute here. and we're going to leave the 7x alone. That's not getting multiplied by anything. It's just going to get combined with like terms in the next step. So I'm going to do 1/2 times x, 1/2 times negative 16, negative 3 times negative 5x, and negative 3 times negative 8. That negative sign or minus sign is a part of that 3. We're distributing negative 3 into both of these two terms, negative 3 times negative 5 and negative 3 times negative 8. That's what I'm showing here. That sign is a part of that number. That gives us 1/2 x, that gives us negative 8, that gives us 15x, and that gives us 24. This one I am actually going to write out. Well, no, never mind. I'm just going to group my like terms. I'll circle these guys in green, and I'll circle these guys in blue. I'm going to change this into a decimal. That's the same thing as just 0.5x. So 0.5 plus 7 plus 15, that's 22.5. It's possible you could see that as a fraction. I don't think you need to, though. I'm just going to change it into a decimal just for convenience. And then my constants, negative 8 plus 24, that's positive 16. All right, here we have an area model. We're trying to select the expressions that represent that model. So I'm just going to label what we have here. I don't think it's clear on your paper, but this is a negative x block. That's a negative x block. So are all of these? They're each one negative x blocks. So we have 4 of those there. So we have negative 4x. Here we just have single squares. So that's positive 5. Actually, I'm going to write it out for all of them. I have another negative 4x plus 5, another negative 4x plus 5, and another negative 4x plus 5. The reason I did that is because I see that answer directly here. I have negative 4x plus 5 4 times. That's exactly what I'm shown in that picture. This one is just showing it one time. That can't be it. It needs to show it 4 times. That represents one of the circles, but not the entire model there. This is a simpler way to write it. It's saying we have that expression, this negative 4x plus 5, and we're multiplying it times 4. We have 4 of those expressions. That's exactly the same thing as writing it out as a big addition problem. The last one's close. If we distribute that 4, it would really give us negative 16x plus 20. So this could have been the answer if that was negative 16. They just multiplied wrong, so that's not correct. All right, which is the correct application of the distributive property to simplify that given expression? So what I would do is take the 3 and distribute into both of those. So I would do 3 times 2x plus 3 times, that's a 2, plus 3 times 4. The first one's showing the original expression plus another one of those original expressions. It just wrote it twice. That's not the same thing. Second one looks like by accident they put these two together. 2x plus 4 became 6x, but that can't happen. Those aren't like terms. We're not allowed to put those together. This one's written a little bit different from how I wrote it. I wrote it with a multiplication symbol, but remember, parentheses means the exact same thing. That's exactly what we're looking for. And I don't know what went wrong there. Maybe we just kind of squeezed these two together and made it 24, but can't do that. That's not the same thing. So that is the distributive property. Given an area model, given these complicated problems, hopefully this helps. If not, ask for some help.